Hi everyone, welcome back to my channel. So today I'm going to talk to you about factoring binomials, okay? And specifically we're going to focus on differences of perfect square formula, okay? All right, so let's try to understand this topic. All right, so differences of perfect square formula says a square minus b square is equal to a plus b times a minus b. Okay, so this is what we are going to use today to solve all the problems. Okay, this is called differences of perfect square formula. Okay, all right, let's take a look at example number 1. Okay, example number 1, x square minus 1. So the whole idea is we want to write this in such a way so that we can apply this formula. Okay, so I want to have something square minus something square. Okay, so x square, think of x as x square minus 1. Well, 1 can also be written as 1 square, isn't it? Okay, so think of x like a and think of 1 like b. Okay, so I can write a plus b, so x plus 1 times x minus 1, and that's it. You are done. Again, you should always double check your answer by applying distributive property. So if you apply distributive property, you should get this. Okay, so that's how you can double check the answer. So my advice is always apply distributive property. Okay, so we are done with this problem. All right, let's take a look at example number 2. All right, so example number 2 says 4x square minus 25. What we want to do, we want to factor this problem, right? How can we factor this problem? So we want to have something. Okay, so the first question you should always ask, can we factor something out? So the answer is no. We have 4 and 25. Only one goes into both 4 and 25 evenly, so we can't factor any constant out. So the second option that we have is called differences of perfect square. So something square minus something square. Now what should I put here? So sometimes some students use this notation. So what they do, they basically take square root of both term. Okay, so you can also do that. So square root of 4 is 2 x square. Square root of x square is just x, so just 2x, right? So the whole idea is you can write 4x square as 2x whole square. Okay, now 25 can be written as 5 square. So 5 times 5 is 25, so you can write 5. Once you do that, it kind of looks like this differences of perfect square formula. As you can see, a square minus b square equal to a plus b times a minus b. So first term square minus second term square equal to first term plus the second term times first term minus the second term. So that's what we are going to do here. Okay, so this is going to be 2x plus 5 and 2x minus 5. Again, how can you double check all the answer? You can apply the distributive property. Okay, and we are done. All right, let's take a look at example number 3. All right, example number 3 is 2 minus 18x squared. As I say, the first question you should always be asking, can I factor anything out? So let's take a look. I have 2 and 18. So what's the biggest number that goes into both 2 and 18? It's 2. Yes, it's 2. So So it's 2, right? So I'm just going to divide by 2. Divide by 2, I have x square and no x term here. So that basically means we cannot factor out any x, okay? So we are just going to factor out 2. So if we factor out 2, 2 divided by 2 is going to be 1, minus 18 divided by 2, 9x square, right? Okay, wonderful. So now we have actually written down this binomial as a product of two different factors, right? Now the question is, can we simplify this a little bit more? And the answer is yes, we can. So take a look at 1 and 9x square. So think of it this way. Square root of 1 is 1, square root of 9x square is 3x. So they're perfect square. So we can actually apply differences of perfect square here, right? All right, so let me show you what do I mean. So 1 can be written as 1 whole square. 9x square can be written as 3x whole square, right? Okay, let me use one more parenthesis so then you don't get confused. Okay, all right. So 2, now we can apply differences of perfect square formula. So that's going to be 1 plus 3x and 1 minus 3x. So what we basically did, we wrote down this binomial as a product of 3 different factors, okay? Now how can you double check your answer? If you multiply all 3 of them, you should get this back, okay? All right. So I hope it makes sense. Again, let me know if you have any question, any concern. Let's do one last problem, okay? Let's do one last and let's see. Let's do one more. Okay, example number 4 says 100 minus 25 x raised to the power 4. I hope all of you remember what's the first thing that I told you to remember. The first question you should always ask, can I factor anything out? The answer is yes, we can factor out 25. So 25 is the biggest number that goes into both 25 and 100. We cannot factor out x because there is no x term here, okay? So I am just going to factor out 25. That's going to give me 4 minus x square. All right, so now obviously the question is, are we done? Can we simplify this a little bit more? So what do you think? Can we simplify that this a little bit more? The answer is yes, we can simplify this a little bit more. So think of it this way. Square root of 4 is equal to 2, and the square root of x raised to the power 4 is just x raised to the power 2, so we can. Okay, so 25 of 2 square minus x raised to the power 2 square. Let me use a different color. All right, so again, we haven't changed anything. 25 remains the same. Okay, we haven't changed anything. 25 remains the same. 4 2 square is equal to 4 minus x raised to the power 2 raised to the power 2 x raised to the power 4. So we haven't changed anything. Now can we apply differences of perfect square formula? Yes, so that's going to be 2 plus x square and 2 minus x square. Okay, all right, let me put this 2. This 2 doesn't look that good. Let me put this 2 on top of this 2. Okay, and that's it, we are done. Thank you for listening. Take care. Bye.